All right, so we're going to start off by graphing this polynomial. And so I see that it's degree 3 positive, so I can do the end behavior right off the bat, so it's going to be looking like a positive slope. I think that grouping will work here. Let me check that out. So if I group it, then I can GCF a 4x squared out of the first group, which leaves me with 2x plus 3. And then the second group, I can take out a -9, which will leave me with 2x plus 3 as well. So that will work. So we get 4x squared minus 9, and then 2x plus 3. And so then I'll break this one apart as 2x plus 3 times 2x minus 3. And then since I have this 2x plus 3 right there, what I can actually do instead is I can cross that off and then just put a squared right there. And so that tells me that my zeros are at -3/2 with a multiplicity of 2. And then positive 3/2 with a multiplicity of 1. So at -3/2 is like -1.5, so that's going to be right there. And we know that that one's the bouncer because it's multiplicity 2. And then the other one's at 1.5 right there. So this will bounce off right there and then cut through right there. And so then we'll use the graph to determine where it's above 0. So I kind of think of these as positives and these as negatives. So where it's above 0 is just from 3/2 to infinity. And then where it's less than 0, since I have to kind of think of these for this answer as open dots since it's not included, I cannot combine those two intervals, so I need to keep them separate here, like this. All right, next up it says find all the zeros given that 6 is a 0. So I know the grouping wouldn't work here because the ratios are off, but so it's really nice that they gave me a 0. So I don't have to do my P over Q. I'm just going to use the one that they gave me to start off with. So then I'm going to bring this down, and I'm going to put a 6 there, and we got -6, -36. Let's see, this will be a 5 and 25. And that'll be 150, and that'll be 0. So I have x minus 6 times x squared minus 6x plus 25. And then I can try to factor that multiplying 25 and adding to -6, but it doesn't work, so I'm going to use quadratic formula. So 6 plus or minus the square root of 36 minus 4 times 1 times 25. And then that's all over 2. So this will be 6 plus or minus the square root of 36 minus 100. Which would be -64. And so the square root of 64 would be 8, so this would square root of -64 would be 8i over 2. And I reduce that, so I get 3 plus or minus 4i. All right, next up here, we're going to write the polynomial. Now, when they tell us imaginary zeros, remember that their conjugates are also zeros as well, even if they don't tell you. So I'm going to add those conjugates in. And then I'm going to build my polynomial. So I'm going to do x minus I, x plus I for the first two, and then x minus 4 minus I and x minus 4 plus I for the next two. Remember that when I build my factors, I always switch the signs from the originals. This one I can actually do a foo because these are definitely conjugates. So it's going to be x squared minus I squared, which is really just plus 1. This one, I'm going to multiply it with the box. So we're going to do x minus 4 minus I. So x squared minus 4x, and then xi, negative 4x. 16 right there, negative 4i, negative xi, and then positive 4i, and negative I squared. Now, you can see that these all cancel out, and then this one is really plus 1. So I'm going to combine that with the, I'm going to combine like terms here. So I have negative 8x from the negative 4x, and then I have plus 17 from the 16 and 1. So now I need to multiply these together as my last step. So I'm going to multiply this one by x squared plus 1. So I get x to the 4th minus 8x to the 3rd, and then 17x squared, x squared, negative 8x, and then positive 17. Just combine like terms for my final answer. X to the 4th minus 8x to the 3rd, plus 18x squared, and then minus 8x plus 17. All right, next up here we have x cubed minus 27, and they want us to find all the zeros. So I would actually first off factor this so we can get all the zeros. So this is our perfect cubes, like that. and then we'll go same, opposite, always positive. So then obviously this one's going to be x equals 3, but this one we're going to have to do quadratic formula. So on these, it's always going to give you kind of one real answer and then the two imaginaries. So I'll do 9 minus 4 times 1 times 9, and then all over 2. So that'll be negative 3 plus or minus, let's see, 9 minus 36. It's negative 27. So 27 does break down as 9 and 3 and 3 and 3. So since that's negative 27, I can actually just call that 3i rad 3 all over 2. I don't see anything simplification I can do, so I'm just going to leave my answer like that. All right, next up, we're going to build another polynomial here. So we have a 0 at negative 3 with multiplicity of 2. So you can write x plus 3 squared. I'm just going to write it twice since I know I need to expand that. Negative 5i would be x plus 5i. However, we know that if I have an imaginary one, it always goes with the conjugate. So these two I can glue together, so that's going to be x squared plus 25. And these ones I need to do a full FOIL, so it's going to be x squared plus 3x is plus 6x, and then plus 9. So now I need to multiply those two together. All right, so we get x to the 4th, 6x to the 3rd, 9x squared, 25x squared. That'll be 150x, and then let's see, if I have 9 quarters, that's $2.25. All right, so now I'm going to combine like terms here, x to the 4th plus 6x to the 3rd, and then combine those, so that's 34x squared, and then 150x, and then 225, and then that's it. All right, next up, number 6, I think grouping looks like it'll work here. Let me double check. So I pull out the x squared, I get x minus 5. I pull out a 4, I get x minus 5 as well. I know it's going to work because we get the same thing inside of both parentheses. So it's going to be x squared plus 4 times x minus 5. This one I can actually factor again using imaginary numbers. It'll be plus 2i and then minus 2i. Same thing as the x squared minus 4, except with i's attached. So then I can get my zeros at plus or minus 2i and then also 5. All right, next up here, they want us to sketch this graph. So first of all, I would count the degree. So it looks like if I add up all those exponents, it is degree 9 and it's negative. So I know that the graph is going to have end behavior like that. And then my zeros, I'm going to have one at 0 for that negative 2x to the 4th out front with a multiplicity of 4. Negative 5 over 2 with a multiplicity of 2, which will also be a bouncer. 2 with multiplicity of 1, and then 4 with a multiplicity of 2. So you just need to draw these all in here. So we'll draw one at 0. Negative 5 over 2 is like negative 2.5. And then positive 2. And then positive 4. Looks like this is going to be the only one that cuts right there. So all the other ones are going to be bouncing. So I'm just going to bounce off and stay up here. Bounce off again. I'll cut through there. And I'll bounce off again at 4 and go down. All right, next one says use synthetic division, prove that negative 1 is a 0. So put negative 1 in the cupboard. Because it didn't give me the factored form, I'm not going to switch the sign. And I'm going to put 1 there, 0, negative 1, 2, and 2. So I'm going to bring this down as 1, and then negative 1, 1, 0, and then 0, 2, negative 2, 0. And the fact that this is 0 is actually the proof of this. So there's no real answer. It's just kind of your work showing that that remainder comes out to 0 proves that negative 1 is a 0 of the function. All right, next up here, it's asking to find the solutions, express them in a plus bi form. So this is just asking for some quadratic formula. So I'm going to let you guys try that one on your own. All right, next up, number 10. So this one, I noticed that we have a GCF here, so I'm going to take that out first. And I have 4x squared plus 2x plus 1. I'm going to try to factor this multiplying to 4 and adding the 2, but it doesn't work out. So I'll have to use quadratic formula on the inside there. And so it's negative 2 plus or minus square root of 4 minus 4 times 1 all over 8. So negative 2 plus or minus the square root of 4 minus 16 all over 8. Negative 2 plus or minus the square root of negative 12 over 8. And we'll break this down as a 4, 3, 2, 2. So the twin 2's will go outside. It was negative in there. So we're going to take out 2i and go rad 3 all over 8. Then we can reduce everything and call it negative 1 plus or minus I rad 3 all over 4. Oh, also x equals 0 with multiplicity 2 is zeros because of this x squared we pulled out. Next up, number 11, I would GCF first, so it'll be x times x squared plus 81. And then I can actually factor this one as x plus 9i, x minus 9i. Same as x squared minus 81, except since it's plus, it's imaginary. So we get x equals 0, negative 9i, and 9i. All right, next up, number 12. So it has the fish population. Find the zeros of the function. So I'm going to put a 0 right there. I would GCF a negative 100, which would leave it as t squared minus 17t minus 30. You can try to factor it from there. But I don't think that works, so we'll go ahead and use the quadratic formula here. So we'll do x equals 17 plus or minus the square root of 17 squared minus 4, I'll just do that, 289 minus 4 times 1 times negative 30 over 2. So 17 plus or minus, I'm just going to do the square root of 289 minus 4 times negative 30. It's going to give me 20.22 all over 2. And so if I actually calculate that out, 17 plus 20.22 over 2, it's going to give me 18.61. And then 17 minus 20.22 over 2 is negative 1.61. And so what do they represent? I don't want to write this down, but I'll just kind of verbalize it here. So they represent the amount of years until there are no fish left, because these are x values in years. Now, only the positive one really makes sense here. So it's saying after 18.61 years, all the fish will be dead. Obviously, a negative answer for time is kind of irrelevant. All right, next up we got number 13. It's some more quadratic formula. I'll let you guys try that one. All right, next up, we're going to do some long division here. So we'll go ahead and put the 8x to the third plus 10x squared plus 17x right there. I'm going to go ahead and put plus 0, and I'll put 2x squared plus 3 out there. So we start off with first thing inside divided by first thing outside. So that'll be 4x. We're going to multiply that by the front, so that'll be 8x to the third, and then 12x right there. We have to change those signs, so when we add down, we get 10x squared plus 5x plus 0. And I'll do one more round here, so we'll do first thing inside now is 10x squared divided by 2x squared, and that's 5. So plus 5, and then we'll multiply that by the front, and put it underneath, change the signs, and add down. So it'll be 5x minus 15. It didn't ask us to write it as a fraction, so I'm going to say this is the quotient, and then this is the remainder.